All right, we are covering 5-5, indirect proofs and inequalities in one triangle. We're kind of skipping over the indirect proofs because it's just a very small part of it and going to go to the inequalities in one triangle. So take something out to take notes with and do the check it out problems.
We have one learning target today. I can apply inequalities in one triangle.
All right, so we have theorems that tell us about the relationships between the sides of the triangles and the angles. So as it says here, the positions of the longest and shortest sides of the triangle are related to the positions of the largest and smallest angles. So theorem 5-5-1, if two sides of a triangle are not congruent, then the larger angle is opposite the longer side. So in this example, AB is larger than BC, so the angle across from AB, which is angle C, is going to be larger than angle B, and that's what the conclusion is. Angle C is larger than angle A, not angle B.
Nice.
Thanks. And then 5-5-2, if two angles of a triangle are not congruent, then the longer side is opposite the larger angle. So here it's telling us that angle Z is larger than angle Y. So that means the longer side, which is XY, is going to be longer than the side opposite angle Y, which is XC. So XY is greater than XC. I finally made it through that.
So here we want to write the angles in order from smallest to largest. So let's look at the sides we've got, looking for angle smallest to largest. Angle G is going to be our largest because it's opposite the longest side. Angle F, so measure of angle F is going to be less than, it's at 17.2, measure of angle H, which is going to be less than, ooh, that looks like an angle sign, less than the measure of angle G. And now we're going to, for B, we're writing the sides in order from shortest to longest. So 180 degrees in triangle, this is 132. 180 minus 32 is what, Ms. Briscoe?
180 minus 32?
Minus 132.
Oh, it's going to be 48.
Whew, took two of us for that one. So the shortest side is going to be opposite the smallest angle. So segment PQ is going to be less than segment QR, which is less than segment PR.
All right, here's your check it out. Write the angles in order from largest to smallest on this one, and then here you're writing the sides in order from shortest to longest.
So now we're going to look at triangle inequality theorem. And so angles or triangles formed by three segments, but not every set of three segments can form a triangle. We looked at this earlier in the year, why things won't work. So here we have sides are 3, 3, 3, and 7. We just don't have, they don't meet here, but 4, 4, and 7 do. Because it follows the triangle inequality theorem, which states the sum of two side lengths of a triangle is greater than the third side length. So here we have these two side lengths, 4 and 7 is 11, which is greater than 4, and 4 and 4 is 8, which is greater than 7. Here, if we did 3 and 3 is only 6, which isn't greater than 7. That's why we don't make a triangle up here. So make sure you take that in your notes.
All right, so tell whether a triangle can have the sides with the given lengths. Explain. So the first one, 7, 10, 19. So remember, triangle sum says the sum of any two sides has to be greater than the third. 7 plus 10 equals 17, which is less than 19. So this is no, it can't be a triangle because two sides added are shorter than the third.
Doesn't follow the triangle inequality theorem.
All right, we get to go into decimals on this one.
Yeah.
So we'll start by adding 2.3 plus 3.1, which is going to be 5.4. That is greater than the third side. So that one works. 3.1 plus 4.6 is going to be 7.7, which is greater than 2.3, the third side. And then finally, 2.3 plus 4.6 is equal to 6.9, which is greater than 3.1.
Do we have to do all three sides?
No, the shortcut way would be to take the two shortest sides. So if the two shortest sides work, then the other two will work as well. So for completeness, you might want to try all three, but you don't really have to. So yes, because all sides are greater. Whoops, not that. So the reason all sums greater than third side. Oops, your head's in the way. Still there. Okay, and the last one, it says the side lengths are n plus 6, n squared minus 1, and 3n. Will it work when n is equal to 4? So I'm plugging 4 in for n and then check using triangle inequality theorem. And so, is that the name of it? Inequality?
Inequality theorem. Yep.
Okay, that
Yep.
sounds strange.
That's why we're using inequalities everywhere.
Okay, 4 plus 6, so this is going to be 10. This is going to be 4 squared minus 1, so this is going to be 15. And this is going to be 3 times 4, or 12. So if we take our two shortest sides, 10 plus 12 is 22, which is greater than 15. So the answer again here is yes.
Nice. Now it's your turn. You have 3 check it out problems to do. Good luck.
All right, the lengths of two sides of a triangle are 8 inches and 13 inches. Find the range of possible lengths for the third side. Okay, to solve this kind of problem, we know two sides are 8 and 13. We don't know what the third side is, so I called the third side x. It's a variable. We don't know what it is. So if these are the 3 sides of our triangle, we set up our inequalities. We know that the side that's 8 plus the unknown side has to be greater than 13 because that's the third side. We know that 13 plus x has to be greater than 8. And we know that 8 plus 13 has to be greater than x. So we solve for x. Here we subtracted 8. Here we subtracted 13. Here we just combine the two numbers. And we get x is greater than 5. X has to be greater than negative 5. And x is less than 21. We can't have a side length that's negative, so we kind of just ignore this one. So what do we know then? We know that x has to be less than 21 but greater than 5. So if we write that, we can write that as one inequality. You put the x in the middle, put your two less than signs, and then your smallest number goes there and your biggest number goes here. And this says x has to be greater than 5 but less than 21.
Yep, we're just writing a compound inequality. And now it's your turn to do that. Good luck.
Okay, so this shows, this has a picture of a triangle that is showing distances from Oakland to San Jose
San Francisco.
to San Francisco. And they want to know the range of distances from San Francisco to Oakland. So they want to know what
Possible values for x would be.
correct. So we're going to set up our triangle inequalities. So 46 plus x has to be greater than 51. 51 plus x has to be greater than 46. And 46 plus 51 has to be greater than x. I solve for x and I get these 3 inequalities. And again, we cancel this one out because we can't have negative distance. And that leaves us with x has to be greater than 5 and less than 97.
And now it's your turn. You're going to find distance from Seguin to Johnson City.
San Marcos.
There you go. Yep.
All right, so we are done. Indirect proofs and inequalities in one triangle. The triangle inequality theorem says the sum of any two sides of a triangle is the length of the sides is greater than the length of the third. And to show that the 3 lengths cannot be the sides of the triangle, you need only to show that one of the 3 sides is false. And if you check the 2 shortest sides, that's going to probably be the shortest, the quickest way to do that. So the shortest side length is opposite the smallest angle, and the smallest angle is opposite the shortest side. And we can solve for a range of possible side lengths using the triangle sum theorem. All right, we will talk to you next time.